Hello grade 9s, worksheet 7, and we are now going to bring in the theorem of Pythagoras. We have done the theorem of Pythagoras during the lockdown, so we're going to use it together with everything else we know to solve problems in diagrams. Right, just quickly to remind you about the theorem of Pythagoras. It applies to right angle triangles. There's your right angle. So, and in a right angle triangle, if it's triangle ABC, the theorem of Pythagoras says that the square on the hypotenuse, remember the hypotenuse is always opposite the right angle, is equal to the sum of the squares. So this square plus that square on the other two sides. And if we write it mathematically, we say that the square on the hypotenuse, which means it's AB squared, is equal to the sum of the squares on the other two sides. So side AC squared plus the square on the other side, CB squared. Or we can alternatively, remember in a right angle triangle, the side opposite angle C, we can also label it with a small c. The side opposite A with a small a, and the side opposite B, angle B with a small b. So alternatively, I can write the theorem of Pythagoras as c squared equal to a squared plus b squared. Right. And we use the theorem of Pythagoras if we want to determine the length of sides. So we are going to look at your worksheet 7 again, and we are going to look at your first problem that you had to solve. So you will see that the diagrams in worksheet 7 is becoming a bit more complicated. There's a lot of information in it. So let's just quickly start with the information that is given. So that tell you that ACDE is a kite. So that is ACDE. And when they say a kite, you must know the properties of a kite. So the first thing that you know about a kite is that adjacent sides are equal. So CD is adjacent to DE. So this side will be equal to that side, and you also know that this side is equal in length to that side, so they are equal. Right, then you also know that perpendiculars are diagonals are perpendicular. There's no diagonals in this diagram, so we're not going to work with that. So, and we also know that opposite these two angles are equal. Right, so that is the kite. And then I also give you in this diagram, ABDF is a square. So properties of a square. Square is the one that you know best. We know that all four angles are 90, so let's put them all in. So it's got 4 90-degree angles, and we know that all four sides are equal in length. So let's mark them. Right, so that is the information what that is given there. They tell you that AB is equal to BC. Then they also say that angle C1, which is this angle, plus C2 add up to 96 degrees. So if this one is 96, it means that this also add up to 96. You can put it in there. Right. Then they say, and AC is 12 centimeters. Side AC is 12 centimeters. So this is what I've got. Then they say, calculate with reasons the length of AE. So AE is this side. Do you need to calculate AE? Let's start to our formal answer. You need a statement, and we need a reason. So what did we mark on the diagram? We said that adjacent sides are equal in length because it's a kite, which means that AC is equal to AE. So if AC is 12, what is the length of AE? Yes, it's also 12. So that one you can just write the answer. I can say AE, you can write this as if you want, is equal to AC, is equal to 12 centimeters. And what is the reason for that? It's a property of a kite. So you can say it's adjacent sides are equal, or it is a kite. Right. So that part we've done with number. So for number 2, they want the length of CE. CE is from there to there. And CE is part of this triangle. So ladies and gentlemen, what kind of triangle do we have here? We have a right angle there. That is from the square, which means I can use Pythagoras. So let's see which sides are which. Side CE is the side that's opposite the right angle. Can you see that? So CE is then the hypotenuse. So I can use the theorem of Pythagoras and say that CE squared must be equal to the sum of the squares on the other two sides, which means it's AC squared plus AE squared. And the reason is this is Pythagoras. Right, so now I can substitute because I know what the length of AC is, that's given, and A is equal to AC, so it's going to be equal 12 squared plus 12 squared, which is going to be 144 plus 144, and that is going to be equal to 288 centimeters squared. So CE squared is equal to 288 centimeters squared, and then to get CE I get the square root on both sides, and I get CE is equal to the square root of 288. And you can go and work this out. I'm trying to save some time here. So we are done. We've got CE. Then they ask us the following. This is number 2. Done. Number 3, they want the size of angles C1 and C2. I know that C1 and C2 together add up to 96 degrees. But I must get the size of the separate angles. So let's look at angle C1. Angle C1 is an angle in triangle ACE. And what kind of triangle is ACE? We know that this side is equal to that side. There is a diagram signal. So I know that angles opposite equal sides are equal, and that C1 must be equal to E1. And I also know that angle A is 90 degrees. So let's write that for number 3. I'm going to say angle A plus angle C1 plus angle E1 must be 180 degrees, and the reason will be the sum, the interior angles of a triangle. Right, so I know A is 90, and I know that, okay, plus C1 plus E1 must then be 180. But what do I know about C1 and E1? So you can write here, but C1 is equal to E1, and the reason is its angles opposite equal sides. Right. So because we want C1, I'm going to say that C1 plus E1 is the same as 2 times C1. So I'm going to rewrite my statement, and I'm going to say 90 degree plus 2 times angle C1 must be 180. And because I want C1, I'm going to use equations. I'm going to subtract 90 on both sides, minus 90 minus 90. And I'm going to get, that will give me 0. And 2 times angle C1 will be 90 degrees. And to get C1, I divide with 2 on both sides. And I'm going to get angle C1, that 2 cancels out, is equal to 45 degrees. Right, I've got that part. But I want C2 as well. So what do I know about C1 and C2? They add up to 96 degrees. So I can use that. I can say angle C1 plus C2 is 96 degrees. And what is the reason? The reason, guys, are going to be, it is given. I told you that, so you don't have to give another reason. I substitute. I know that C1 is 45 plus C2 must be 96. And I'm going to get that angle C2 is equal to 96 degrees minus 45 degrees. And that is going to give me 51 degrees. And that one is done. So I've got C1 and C2. I've answered number 3. Done. So I'm only left with the last one, the value of x. So let's look at my diagram. What do I know now? I've got now this is 45. And I know this one is 51. But I know that this angle is equal to that one, which means that E2 is 51 degrees and C1 is 45 because they are equal to each other. So now we can use the triangle again. I'm going to work with triangles CDE, and I'm going to work with the sum of angles. So I'm going to do this here. And I'm going to say my statement is angle C2 plus angle E2 plus x, because that is what I need to get. I need to get angle x here. Must add up to 180 degrees. And my reason will be sum of the interior angles, the triangle, right? So now I can substitute. Because I know what C2 and E2 is, so I'm going to get 51 degrees plus 51 degrees plus x must be 180. So if I simplify on that side, I get 102 degrees plus x equals 180 degrees. It's an equation. So to get x on its own, I minus 102 on both sides. And that becomes 0. And I'm going to get x is equal to, that is 78 degrees. And that is number 4. And I am done. Right, ladies and gentlemen, I hope you enjoy this geometry. Have a nice day.